Our objective for today, I can identify, define, and graph relations and functions. Read together. 1, 2, 3. I can identify, define, and graph relations and functions. So once again, relations and functions are still within the same concepts of two-variable equations. But this one is a special concept that I want to address today before we move on. So we're doing three things: identifying, defining, and graphing. So let's look at the steps. You don't need a Fair model, just the steps. Look up. Here are the steps. Steps 1, represent the ordered pairs as a table, mapping diagram, and graph. How many different ways? 3. 1, 2, 3. Step 2, identify the domain and range of the relation or function, also known as set of ordered pairs. Step 3, define the relation and function. So three things that we're doing today: representing, identifying, and defining. Copy those steps, please. There's some terms in here that we need to revisit because maybe some of us forgot what they mean. So the ones I'm going to revisit right now are ordered pairs. I'm going to revisit domain and range, and I'm going to revisit relation and function. These last two might be new to you, but the other three should be something you covered before. But if not, that's why I'm going to go over them, okay? So write your utensils down, look up to the screen. I'm going to go over those terms really quick. So I'm going to start with the first term, which is one that you're already familiar with, known as ordered pairs. Who remembers those? Ordered pairs. And they're also known as a coordinate. Okay? Now, why are they called ordered pairs? Because, check this out, it's a pair of numbers in order. What's the order? That one number represents a certain variable, and the second number represents a certain variable. So what variable does the 2 represent? X, and the 3 represents the Y. Stay focused, please. So 2 is the X, 3 is the Y. That's what we call an ordered pair. Are we clear so far? All right. Next. The next term is a relation. What is a relation? A relation is a collection of ordered pairs. Well, let me see. 2, 3. Is that a relation? No. What do we call that? An ordered pair, because it's only one ordered pair. But to make it a collection, we need at least how many? 2. So what if I do this? 3, 5. Is this a relation? Yes, as long as you have 2 or more of those coordinate planes or ordered pairs, it becomes a relation. Are we there so far? Okay, stay focused, please. Please, pretty please. Next, a function. A function is a relation that assigns exactly one output value for each input value. And I'll show you that in a little bit. Okay? Next, domain. Look at the color. It's red. Look at my ordered pair. What do you think this is going to be related to? The x value. So the definition for a domain is all x values of a relation or function. So look, let me go back to this. Let's say I gave you the relation for 7. Look at it. And I said, can you give me the domain? Domain. Does everybody have it in their noodle? Okay. Charlie, go. Domain. Everyone help her out. 2, 3, and 4. Please stay focused. Please, pretty please. All x values. Are we there? Therefore, tell your neighbor what you think the range is. Yes? That is correct. All y values. Therefore, what is the range? Samantha. 3, 5, 7. Hands that agree with that? That is correct. So the range is all x values. The domain all x values, the range all y values. You got that? All right. So now that we're done with basic vocabulary, let's move on to the next step. Here we go. Here goes an introduction of the coordinate plane. Now, in the past, your teachers already taught you the fundamentals of how to graph coordinate planes, yes? Today I'm going to show you, or I'm going to introduce you as to why we use it that way, okay? So check this out. We started the school year, and we started with the real number line, didn't we? Did you guys ever notice what was the most used variable? Anyone? X, that is correct. The most used variable that I used when we covered the number line was X. I did that for a purpose. Now check this out. The first number in the coordinate is which value? X, because it's the first value that we worked for throughout the school year. Does that make sense? So watch. If I gave you the point 2, 3, the first value is what? 2, which is X. All right. But now we have two different values. So look what I'm going to do. I'm going to create another number line. Oh, sorry. I'll do that again. There's my second number line. Everybody there? So let's say somebody walked in and I asked them to graph this. Some of them are going to do this. 2, 3, 2, 3. Right? It's a little confusing because we have how many numbers? 2 different numbers. How many number lines? 2. Well, guess what? Some time back, there was a mathematician, a French mathematician, or Italian, I think it was French, and his name was Descartes. And he said, so if I want to plot more than one value to make it 2 values, and I use 2 lines so that people don't get confused, I'm going to do this. Look up. Who's seen that before? And that's how we get our coordinate plane. That's why this first line is for which value? So what do you think this is going to be? What value is this going to be? That's why this is for the y. Does that make sense now? So you're saying, okay, so how do we plot this? So now that we're dealing with 2-dimension or coordinates, what is my x value for this one? 2. What is my y value for this one? 3. So therefore, both of them meet. We're at about right there. And that's how you graph a point on the coordinate plane. Now, what does Descartes have to do with this? Well, in some books, instead of calling it the coordinate plane, they call it the Cartesian plane. You guys notice his last name here? Yes? Descartes, Cartesian plane. You guys are looking at me like, okay. Any questions how to graph points? No? We got this? All right. So, let's go to the first example. Before the first example, really quick explanation on relations. Relations are a set of different points or different coordinate planes, but we can apply that to anything. So let's say I started a company on getting vending machines on campuses, different campuses. It would look something like this. Look up. Here's my vending machine. Of course, the drinks are going to be 23 cents. We have Coke, Diet Pepsi, Pepsi Water, tea, Coke, Diet Coke. I think this is grape, Dr. Pepper, Cactus Cooler, and grape. And it became really popular, really quick. So if I was to send people out to go get drinks, when they press the button for the soda that they want, it's called an input, and the soda they get out is a output. Are we there so far? Yeah? So right away, my regulars that go to the restroom all the time, Isaac comes and Mr. Q, can I go get a drink? Sure. So Isaac goes, and Isaac gets which one, Isaac? Dr. Pepper when he presses the button, and he gets a Dr. Pepper. All right, comes back. Here comes Nanelle. Mr. Q, can I go? Sure. All right, Nanelle, which one? Coke, and she gets a Coke. All right, comes back. Brody comes on and he's on. Mr. Q, can I go? Sure. Go, Brody. A Sprite. Okay, there isn't any Sprite. Diet Coke. So we go with Diet Coke, and he gets a Diet Coke. Comes back, and all of a sudden that Bree comes back, but she already talked to the people around her, and some people wanted her to bring a drink, so they gave her a quarter. So Bree, which one are you getting? Pepsi, and she gets a Pepsi. How about your neighbor? What is your neighbor getting? A what? A tea. She brings a tea. How about Fatima? What does Fatima want? A grape, and she gets a grape. All right. So if you guys notice, so far so good, yes? So then Destiny goes out, and I give Destiny a quarter to bring me a Dr. Pepper, and she's going to get something else. What are you getting, Destiny? A Coke, and she gets a Coke. So before she gets my soda, question, is this machine functioning correctly? Yes. All right. So far so good, right? For every input, there's exactly one output, yes? She gets her drink, she puts my quarter in, she presses Dr. Pepper, and she gets a grape out. Question, is this machine functioning correctly up to right there? No. Well, guess what? If it's not functioning correctly, all these ordered pairs, since they're together, do you guys notice the ordered pairs? This is an ordered pair, ordered pair, ordered pair. What is the collection of ordered pairs called? Everyone? A relation. However, if it's not working correctly, then we say that it's a relation, not a function. However, look up. What is up to right there? Is it functioning correctly? Yeah, so it's a relation. However, it what? Is a function. Yes, a function. Does everybody understand why? Because for every input, there's one output. Bless you. Let me show you with numbers. Look up, please. I'm going to label this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right? In, out. All right, Dr. Pepper, what was Dr. Pepper? 10, 10. Coke, 1, 1. Diet Coke, 2, 2. 4, 4. Tea is 6, 6. Grape, 9, 9. And then 1, 1. So notice, I press 10, I get 10. I press 1, I get 1. I press 1 again, what should I get out? A 1. Did I get a 1? Yeah, so it's functioning correctly. But look what is my next choice. Bless you. What's my next choice? Dr. Pepper, which is a what? A 10. What's supposed to be the output? 10. And what did I get out? A 9. So therefore, for 10, we have how many different outputs? A 10 and a 9, 2 different outputs. That's why this is not a function. As soon as you have 2 different outputs for one input, not a function. You understand? All right. So with that said, copy this, please. Example 1. Copy the table, the graph, and the mapping diagram. Okay, really quick, for these ordered pairs, I want you to add one more at the end. It's add 2, comma 3. Okay, finish copying that and I'll go over it really quick. All right, let me go over this really quick. It says, example 1, express the relation 2, 3, 4, 7, 6, 8, 2, 3 as a table, as a graph, and as a mapping diagram. Here's my table, here's my graph, and here's my mapping diagram. Also write the domain and range. Bless you. So, before we get started, we already know how to find the domain, and we already know how to find the range. Is that correct? All right, look at it. Tell your neighbor the domain for that relation, please. All right, so I heard people say 2, 4, 6. What do you guys notice that I didn't say again? 2, why not? Because we already have a 2 in there. Next, tell your neighbor the range of that relation. 3, 7, 8. That is correct. Did we repeat the 3 again? No, because we already have a 3. Are we done so far? No? What's that? No, are we done with domain and range so far? Okay, so now let's write our table using these points. What is my first point? 2, 3. So I write 2, 3. What's my next point? 4, 7. What's my next point? 6, 8. And what's my last point? 2, 3. And what did you guys notice? That I did write it in my table this time. Doesn't matter if it repeats or not. I write it in the table. All right, let's plot this. 2, 3. 2, 3 is right there. 4, 7. 4, 7. 6, 8. 6, 8. And 2, 3. 2, 3. It's already there. I'll put it again, but it's the same point. So far, so good? Okay. Write your utensils down. Now, let me go over the mapping diagram. This is the one that it's very special, and make sure you understand it. Here it goes. So 2, 4, 6, 2. I already have it. Okay. Next, 3, 7, 8, and 3. I already have it. Next, I'm going to map it. That's why this is called a mapping diagram. 2 corresponds to which number? 3, so I map it using an arrow. 4 corresponds to 7. 6 corresponds to 8. And 2 corresponds to 3. Question. For each input, do we have exactly one output? Yes. So, first of all, this is a relation. Is that correct? Because we have a lot of points together, yes? However, if we do have for each input one output, this is also a function. Because, remember the function machine? Because it's functioning correctly. I press the 2, I get a 3. I press the 2 again. What number do I get again? The 3. So is it functioning correctly? Yes. Are we there so far? All right. So copy that up to right now, and then I'll do the next step just to clarify. Copy that. All right. So look, let's say I said, okay, guys, up to right there, it's a function, yes? I want you to add one more point to the original problem. Let's add 4, 9. So that one goes down here where? 4, 9. Let's plot that. 4, 9. There it is. So let me put it on my mapping diagram. Do I have a 4 already? Yes. Do I have a 9 already? No, so I write it in here. So let me do the mapping one more time to make sure I got all the numbers. 2 to 3, 4 to 7, 6 to 8, 2 to 3, 4 to 9, 4 to 9. How many different outputs for that 4? 2. So as soon as we see that one input has 2 outputs, guess what? This is a relation, but not a function, because now for the same number, we're getting 2 different outputs. Everybody seen that so far? Okay. All right. So we good up to right there? I'm going to give you one for you to do by yourself. Here it goes. Number 2, example 2. And I'm going to give you one more point. You don't have to copy all the words. You already have the instructions. Just copy the relation. 1, 3, 2, 4, 3, 5, and 1, 7. All right. Make me a table, graph it, and make a mapping diagram. Copy that and go. Oh, also identify the domain and range. Go. Okay, let's see. Your table should look something like this. Your graph, something like this. And your mapping diagram, something like this. But what was the last point I told you to write? 1, 7. So I'm going to write that down here. 1, 7. 1, 7. 1, 7. Question. Is it a function? No, not a function. But is it a relation? Yes, because it's a lot of points together. So the domain, everyone, should be what? 1, 2, 3. Hands if you got that. Okay, good. And the range should be 3, 4, 5, 7. Hands if you got that. Okay, good. Question. Look up, please. Look up, because I have one more example to go to, but I just want to clarify. Tell your neighbor, look up, what number do I need to change in this last point for this to be a function? Tell your neighbor, what number should I change in that last point for that number, for that to be a function? Instead of a 7, it should be what, Mel? A 3, because like that we can have 1, 3, and we already have it, and that will be a function. That is correct. All right. Look up, please. Last example. Writing utensils down. Look up. So, imagine I have right now nothing here. Can you imagine that? Okay. But now I'm going to graph, or I'm going to sketch a little graph over that. And I start by placing a solid point here. Then I go this direction, and there's my other solid point. Okay, do you guys see that graph? All right, so there it is. So now I need to write the domain and range of this graph. But now it's a little bit different. Pay attention, you're going to miss it. Question. On my x values, what is the first x value of this graph? 1. What's my last x value of that graph? 5. Look how I write my domain. 1, 5. It's my x value, less than or equal to, less than or equal to. Why equal to? Because they are solid points. Now look, for my y value, going from the bottom to the top, what's my first y value that touches that one? 3. What's my last one? 3, 4, less than or equal to y, less than or equal to y. Hold on before you leave. Some of you don't understand yet. Well, let me show you. This is my test, vertical test line. So watch. I'm going to go from left to right first to check for the domain. What's the first x value that touches that point? 1. And it ends where? Let's see, at 4? No. At 5. That's how I know the domain. Next, I'm going to switch this over. Now I'm going to scan it from the bottom to the top. There you go. What's my first y value? 3, and what's my last value? 4, and that's how I find my range. Everybody got it? All right, your home play for tonight. Home play is play sheet 4.2. Come grab one on your way out. Just do numbers 1 through, only number 1 through 5. 1 through 5. Only. Good one, guys. Enjoy your home play. See you guys tomorrow. Bye.